Hi, how's it going? Here we have a working prototype for the torque generator for free energy. This is a computer power supply box which is used to encase it, ultimately having this neat little package when we can just have a press of a switch, turn it on with no gas emissions. It can be used any time of day, so we wouldn't need like solar panels because it works with magnets. So here we have the input energy source, and we have this for showcasing, but for demonstration purposes I'm using this negative and positive direct current output wire in order to showcase that there is more power coming out than what is being put into this closed system. In the front over here, I had this. It's a volt amp meter. It shows volts in red. I don't know if you've seen it before, and amps in blue. But it had burned out. I had it epoxied there, so it looked really neat. Sort of like a final product design, with everything functioning as intended. So when I fire it up, here we go. I can plug it into this 12 volt, 1.3 amp hours rechargeable battery, and there we go. There's one, and that'll give a power output of 15.4 watts. Coming out of here, you would have a power output that is bigger than 15.4 watts, and that is the intended functionality of this product. Before I go fire this up, I want to make a note that the inductors used for the generator, if you can see there, I have an AWG of 24, which I would prefer using an AWG of 14. So you still get the same higher voltage, but this 14 gauge would support 15 watts of current, which is pretty standard for like household appliances. This could be charging itself as well with the extra power generated. So as a result, since we're using this 24 gauge AWG, which is given less current, it still gives the higher power output. But as we can see here in the page, 100 to 650 RPM, 50 to 60 watts is what we can get out of it. Just because these wires are not as big as these wires in terms of gauge. Doing this prototype, I refined all of my knowledge on how electronics, work together, and I've noticed, that the inductors of a generator, the voltage is dependent on how many windings of coil. Sorry, I got a phone call. I'm gonna ignore it. How many windings of coil in the coil, and how thick, how fast the rotor is going. That determines the voltage. Now, what determines the current? It's like a signal. You attune it. It's attuned to what the RPM is going at. So if this had a bigger gauge, the wire gauge is what determines the current. So if we had a thicker wire gauge with same amount of windings, same speed RPM coming out of this, we would get, instead of 50 to 60 watts, you would get like around 300 watts of usable power. So for demonstration purposes, I can show it with this buck converter and screen combination. just because my multimeter, it's shot now because I was normally what I do is test the current and voltage. Well, to test the current, we know that we needed a load, so I was just putting it directly, and I guess it blew the fuse of the multimeter. So without further ado, here we go again. We'll plug this in. I'm gonna turn it on. This works with the hard drive motor. So what I do, to get it started, here we go, ready? Yes. It's got a hard drive motor running it. And over here is the ESC circuit. It's much quieter if it was perfectly manufactured. Oh, here we go. Disconnected there. She's dancing around too. Well, just by the feel of it, it's contained. It's definitely making more energy than what I'm putting in because of the interactions of the magnets inside, which I'll show in a bit. Let me connect this buck converter. Give me 1 second. Okay, now we can see it's consuming power because the buck converter is on. Normally, like I said, I would put a load to test the current as well. We can see 36.5 volts. Here, you can, just because when you short it, all the energy generated is being funneled back into the generator. So just shorting it would really short circuit it, will make it completely break. Well, that's why we have things like these. We have a buck converter that can help mitigate that. Or what I've seen is that when I use supercapacitors, you can actually run a device without this slowing down because of all the extra energy generated. The supercapacitors could have, like, say 300 microfarads. That would represent 300 milliamps of reusable power continuously. As they filter out the power being used, it will be rebalanced into from the positive to the negative back into the generator. So when it's shorted, the inductors, they would act as a counterforce. But that's really irrelevant because what we're looking for is making it give usable power. And that's basically what it's doing, because normally you wouldn't short these two wires to use the power. You would just add a load, like this buck converter. It works as a load. And as we can see with the buck converter, is giving readings that are way higher than this 12 volt, 1.3 amp hour battery. Now, I'm gonna open this device. I have 2 upper and 2 lower screws for this prototype. Yeah, just to show the inner workings. Here, 1 moment. I'm just getting these off. There we go. Now, yes, I would go like this. Removing the 2 screws. There we are. Sorry it took a while. Here we are. Just moving this buck converter now. There we go. It was just hooked onto the outputs. Now I'm able to open this and let me see. 1 moment again. Here we go. So now I've opened it. As we can see, this 3-phase output goes to these 3 wires. I ran out of electrical tape. Don't mind that. And on the other side of that is a 3-phase bridge rectifier, which consists of 6 diodes. And then out of that comes these 2 output wires. The yellow is the positive, negative is black. So the battery would power this circuit in the side and the front. This is all that's needed, because this is just an RC circuit to run through brushless motors, 3-phase brushless motors. And that comes down here to run the brushless motor from that circuit, which is a hard drive motor in this case. And on there I have 2 layered magnetic discs. Let's see if I get some light on there. Yeah, there we go. And as we can see, it freely spins, because on top of that, now all these 4 things, these 4 epoxy spots are the same polarities to interact with the stator. That's the rotor of the motor interacting with this stator. That's the part that's patented because of its asymmetrical magnetic force. Now what's going on here, due to the torque being generated being greater than what it would normally have without these extra magnets as the stator and the generator, the extra energy will be transduced by these fixed inductors for the generator. Now, as we said, it would yield a higher current if I had a bigger AWG, but we saw with what we have here that it is indeed giving more power than I'm putting into it, which is the main feature of this invention. Now, before I end this video, I can show that this is, let me see if I can turn on a light here. Yes, that is a 45-degree angle, but this stator, with the 4 magnets of the rotor being south, 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 and 90 degrees from each other, it encounters this south pole, and this north pole is at the top. These 2 magnets are combined with tape in order to make them stronger. But you can have just bigger magnets even for this size generator. So combining those would just amplify the magnetism. So what happens here is that when I'm entering here, you feel a repulsion because it's a linear repulsion. But within the interaction of the stator is 2 planar forces they're biasly pointing forwards. And then so what happens is it's easier to come in this way and it pushes hard out, but coming this way it's a little harder, and when you overcome it, it doesn't push as hard. So that's why it's asymmetrical. Coming this way, it's forward biased. It's like a booster almost, But because of that, you don't see that phenomenon anywhere in nature, except, well, here. This is an invented design. So yeah, this would just be hanging over the rotor, completing the generator, letting this move freely. Instead of a hard drive motor, it'll have a normal, maybe 3-phase brushless motor out of that is conventional for this purpose. But it can still be made into such a neat little package. When I close it, you can close it back. Hold up one moment. Sorry. I don't have nobody to hold the camera for me. That's why I put the camera down. And yes, there we have it. Pretty neat. So instead of those 2 output wires, they would be coming here. there would be the output would be coming from there, which in the patent document, this three-phase inductors will have two of the wires connected to a transformer to make it so that it could stay as it remains as AC current, from three-phase AC to one-phase AC with the transformer. Out of the three wires, you just need two wires, and then from that transformer, the AC current will have the same power, that the increase of power output. Say for instance, if I had, instead of a 50-watt inductor set, I had a 300-watt inductor set, so it would transduce that extra torque into more current as well, not just more voltage. But nonetheless, this still shows that it's giving more power. It could even run this charger, which is for the battery, and charge another battery. Because the charger battery is really, even though it gives 1.2 amps of current, the current for charging is really low. But that's irrelevant. Well, this is an example. So yeah, self-charging, portable power that is not as loud, that gives no emissions, and it's a real deal. It's a proven science. So the patent is almost being in the final stages. It's pending at the moment. It's almost issued, and best wishes to all, really, to create opportunities, maybe learn new sciences. It has a lot of potential in such areas. This concludes this video for now, and I hope you have a good day.